I've been trying to do a video about home-built or shop-built voltage standards. I would like to keep this sort of form factor. And I'll pick one of these circuit boards. I don't want to be cutting circuit boards. And instead of forming little loops, I have these. I showed them in a mail video, but they're little black, and I have red gold loops that I can fit into circuit board holes. For a reference that's less than 5 volts or 5 volts, I intend to use 9-volt battery power. A 9-volt battery is by far clean. Well, any battery is clean power. A 9-volt battery holder with a switch. The 10-volt and multi-volt standards, and I don't know why you would want to build a multi-voltage standard when you can buy them pre-made. And I've got one coming on a slow boat from China. I think they cost, here's a 4 voltage reference module with an internal battery. $17. But a 5-volt reference that uses a chip that is adjustable or trimmed, capable of being trimmed, work well on a 9-volt battery. So I've been accumulating these parts. As I say, these little golden loops, 50 of them cost, well, US, $3. Say $5, who cares? I pulled these out of a box that I don't know where they came from. They're standard sizes that are commonly available on eBay. In general, there's 2 physical things that separate these and many, many more chips. And that's whether they're trimmable. For example, here's a chip that has a nominal output of 5 volts and an untrimmed tolerance of plus or minus 50 millivolts. However, it's trimmable. So I could hook a very good quality meter to it and make this number plus or minus 50. I can make this number into 5.000, maybe 00. Here's a chip. The output is 10 volts. The factory guaranteed is, I believe, there's some errors in this, is plus or minus 5 millivolts. And it's not trimmable. The non-trimmable chip is just the chip. Maybe an on and off switch, maybe a reverse voltage diode, could be an LED. It's just a 3-terminal chip. I'm going to build one of these. And I'm going to use an 8-pin dip socket. I got some here. And I'm going to use these for terminals. And I've settled on this 40 by 60 or 6 centimeter by 6 centimeter. I think I've got 100 of these. So, I mean, these are relatively inexpensive. And hookup wire, well, Cat5 cable is certainly cheap, especially if you know somebody that's in the business and you can get ends of rolls. Well, this is very simple soldering here. Of course, it's upside down, and I omitted this jumper. This was going to be a power jumper, power on off. I may start doing that. Anyway, this is the negative and this is the positive. I don't know how I got that signage backwards. And for these little tiny circuit boards, instead of using the QRP-Me blocks, I use this stick vise. And I got it on Hackaday, but I don't know if it's still there. And I can flop it over. The only thing I have to do is be careful not to, this stick, this is a T I guess, and this is a stick. You gotta be careful not to stick components underneath it. Pretty handy tool. So I need to stick a 3-terminal device in here. And there'll be 3 pins, an in pin, an out pin, and a ground pin, or a negative pin. And in order to do that, I have purchased a generic A51LH, although it's not really. This is the seller's page. You can see it's a 3-terminal device. This is his name, Silicon Sound. And this is his blurb. So what this means is this last 0 could be anywhere from +5 to -5. 5 millivolts above or below 10 millivolts. The analog device L, this comes in 3 different accuracy or precision, I guess that would be. A J is ±30 millivolts, and the L ±5. And this is the pinout from Analog Devices. So there we go. So there you can see these red and black clip leads are not doing anything. They're just making sure these probes make good contact. There's nothing on this end. Okay, this could have read 9995. It reads 9993. Tells me this is 7.3 millivolts out of spec. I'd say something is not kosher with that chip. Let me reverse the leads just because. I've merely reversed the meter leads. There was a negative sign there. And all of a sudden this chip is in spec. I've had that happen before with a calibrated fluke, well, with any fluke. But in the high precision mode, these flukes could be, you held a button down and turned them on, and they started up with one extra digit. And the instructions were to measure from ground to point A or whatever. If I read with the ground, or the negative lead, the VOM on ground, the positive lead on point A, I got a reading intolerance. But if I read the other way around, the unit would have failed. I was told that since it says from and to, that means connect the negative lead to from and the positive lead to, or point A to from to. So look at that. The chip is now in spec, and all I've done is reversed these leads. That's weird. That's just weird. This is being supplied by a linear power supply, and according to the analog meter, it's 16.5 volts. Temperature in the shop, according to my Lamont chemical alcohol thermometer, is 25 degrees C. Received this in the mail today. This uses the AD584, and it produces 2.5, 7.5, 5, 10 volts. I don't know why they don't have them in order. Now the 584 is a non-adjustable chip. This thing costs $14 plus $3.28 shipping. This list is not complete, but the modules are grayed out. Now, I don't know where I got this K series. J and K. And one's about 3 times as accurate as the other. Not on all voltages, but this is plus or minus millivolts. I'm going to try to take a look at this if I can. This chip is marked 584 KH. The KH is the better of the two chips in that it's plus or minus 10 millivolts in the 10 volt scale, while the JH is plus or minus 30 millivolts. So let's take a look at this with the voltmeter. On the 10 volt scale, we're allowed a maximum deviation of 10 millivolts. That's 2 millivolts. It's 2 millivolts high. Let me go to 2.5. Now we're allowed plus or minus 3 millivolts. Well, 3 millivolts would be here, not down here. At the 5 volt scale, we're allowed plus or minus 7.5 millivolts. We're nowhere near that. I mean, we're better than that. So I'll leave this little thing sit until tomorrow or some other time. And we'll read these voltages again to see if anything changes. I'll leave it powered into the power bank. So if you like this video, give me a thumbs up. Subscribe to my site. Send me a question or a comment. I don't really know what I'm doing here. And come back for the next video. Thank you.